Hi, Ethan. I have some comments for you about number 8. Start with A here. So A says that we need to find uh, the viscous force per area. Now they've given us that this is the viscous force per unit area, eta V over D. So viscous force per area is eta V over D. Then they're saying that instead of just the fluid, whose viscosity is defined by this eta coefficient, instead of just a fluid, we're going to have some solid trash in here also, which is going to be taking up some of the space. This gap is a distance d. It separates these solid plates a distance d from each other. And the velocity, I think the velocity is the relative velocity. So one plate's going this way, one plate's going that way. So what's the new eta when you have the solid stuff taking up space here? Well, how much space is the solid stuff taking up? Now they have given us some information about that. They have said that phi is the fraction of the volume between the plates that is filled with solid objects. So phi is like a mole fraction, right? So uh, if a fraction of the volume between the plates is filled with a solid object, and in part A it says the rigid objects are lying in a solid layer of thickness phi d, right? So that means d is going to be so this thickness right here, that is phi d, right? So that means d is going to be reduced by phi d. So d minus phi d, that's the new d. Okay, so the new friction over, the new force over area, the viscous force over area, is equal to the new eta, which is equal to just eta, except there's this new d. So the new d is subtracted by phi d, right? So now I'm going to solve this guy for eta. So eta equals, so the f over a, copy that down, multiply both sides by d, divide both sides by v. All right, so that is eta. And here I'm going to solve for the new eta, which is, all right, so f over a, multiply both sides by d minus phi d, so d minus phi d, and divide both sides by v. Divide both sides by v. Okay, so all right, so this is what I have for part A. So that's part A. Now what I'm doing over here, this is for part B. So for part B, we want to go eta minus eta over eta. Eta prime minus eta over eta. So they want an expression for this. This is this I like because this it seems to cancel a lot of stuff if I'm doing this correctly. So I'm going to say that this is the same fraction as this, and eta over eta is 1, so we're really just talking about eta prime over eta minus 1. Now eta prime over eta, so here's eta prime, that's f over a times d minus phi d. Notice that there's d here, so I can factor out a d later. Over v, that was eta prime, now here's eta, f over a dv. F over a d over v. Okay, now I'm going to write the fraction bar in a new color so that it's easy to discern. This is a fraction over a fraction, so that makes it kind of confusing. I'm going to cross things out with red. Right, so I have force in a numerator and force in another numerator, so they cancel. Area in a denominator and area in another denominator, so they cancel. V in a denominator and V in another denominator, so they cancel. Now I'm going to factor out a, well, let me rewrite this so it's easier to see. So this is eta prime minus eta over eta equals d minus phi d over d. Now if I factor out a d on the top, this is what I get. Oh, I'm sorry, I forgot the minus 1 at the end. And then, so this is, I also need a minus 1 over here. I also need a minus 1 over here. And I have a d down here. All right, so the d's cancel. And so I get a 1 minus phi minus 1. And that is just minus phi. So I think the answer for B is that eta prime minus eta over eta is just minus phi. Feel like that's right. Not completely sure. And now I'm going to do a separate video for C and D because those parts are really hard, and I'm even less sure of my thoughts for those.